Okay, since the last time I did the matrix screensaver, I wanted to optimize, maybe speed it up, and as you can see, it's very sluggish and taking, quite a little bit of time to render across the screen. So this is the old way of doing it. Now, if I reduce the trail, it gets a little bit better, but still it's pretty slow. So um, what I did, let's see, number 6. So that this is the new way of doing it. Basically, what I did is instead of rendering 1 pixel at a time on the screen and moving them, clearing them, all that, I put it into a memory buffer, 2 by 2 matrix of data, and then render that whole object to the screen. Usually, I mean, it's usually how all gaming and most of the graphics are made. You render the output to an off-screen buffer, and then you render the buffer into the screen. So it's like double buffering. It's a bit of a hack here too. I just created a two-dimensional array and then rendered the data there. Initially, I was doing it raw at a time, which was much faster than 1 pixel at a time. But I found out I could just build a whole long string and just render the whole string to the console, and it worked really good. So I'll kind of show you what I did. Of course, the code will be on the GitHub if you guys want to look at it. Um, Pretty straightforward what I did. So this is the old way. Just going looping through it, and I did actually try to do it in parallel. I'll show you that piece just to show that it does a little bit better. All I'm doing is creating a list of tasks and adding them to the tasks, and then uh, well, this doesn't help that much, but let's see what it looks like, if it's any. I tried quite a few different things, but alright, so that's not that great. But if I reduce the trail size, it looks a little bit better. Again, it's functional. Um, but what I did is I created this another function called start buffer mode, and here's the buffer class I created. And if I go into that, it's pretty straightforward. A two-dimensional array, and I'll talk about this a little bit too to get the different colors. But basically, this is the main buffer that I render stuff into. And then as I initialize it here to the width and height of the buffer I need it to be, here the clear is pretty much double looping through all the elements and just clearing it. Now if you were in C++ or assembly, you could do this more efficiently with mem copies and stuff like that, but just trying to do the basic way of doing things. I don't know if C# has it. I haven't even looked if it does anything like that, but then you have to get to low level um, stuff, which I didn't want to get into. And here, so here, setting the position, X and Y position, and then putting the character in, and then the color into the color buffer. Again, I'll talk about that in a second. And then the rendering, it's pretty straightforward. I'm building a string, so we're using string builder. This is more efficient than just using the string. and I build one element at a time, but it's building it in memory, so which is much faster. And then at the end, I put it in the console. And the color part was difficult because if it's inside a string, it's just one string, and I didn't know how to do that because there was no way to do that. I thought there was no way to do that, and I was doing research and I found out there are special ASCII codes you can put in that actually gives us color, and that's what these escape strings are essentially. And so there's another buffer in the same matrix, and if I wanted to change the color, I essentially add that before I render I add the color to that string just before I did the actual buffer character. So it's a kind of a hack. I don't know if it will work on Linux and Mac. I'll test that and let you know later. But I know you had to do UTF-8. So a little bit of hacking around to get here, but I got it working. So pretty straightforward. The buffer is just a two-dimensional array, and then just plop it to the screen. Here is that array being initialized, and then even this clear I could actually done it with the buffer too, but that's doing it the old school way. Here I'm building up all the objects that gets rendered, and then the objects just have XY position, and I did some optimizations on that too. It's work in progress, but I did add a move, so the move happens especially for this case, that it's just going up and down and whatever, but the move position can be sent in so that it'll keep adding them. The reason for this locks is so that it in a race condition, multi-threaded, if it's doing that, it doesn't get in twice. You can do it with semaphores, and it can get complicated, but this is just to add some protection because I wanted to call it from multiple threads as much as possible. And here I believe, yeah, here's where I'm actually putting the colors in for the trail. The colors, like I mentioned, these are color codes for different shades of green back to gray. So and that's it. That's pretty straightforward. It was simpler than I thought, but I played around for quite a while before I got to that point. So, and even this actually is on a delay, and the trail is I believe it's a random trail length. I think we can go look at it, but there's actually even delay on there. But if you make it too fast, it does not look as good. Let me go to this one here. I do have a small delay, so if I get rid of that, it'll run pretty quick here. It doesn't look as pretty, so and I think the trail length, I believe, yeah, it's between 10 and the height -5, just some arbitrary thing I came up with. I did offset I had a couple of times the Y. I need to figure out the randomizer, but I didn't feel like doing too much of that. So if it was the same Y twice in a row, I just incremented one. it's kind of lame, but you know, just to make it look pretty. So I'll put this back. I think let's try 25. Yeah, that's too fast. Alright, so let's do 80 or something. Cool. And of course, pi was another ASCII character, not ASCII, extended character that I found. Unicode character, I believe. Yeah. So I tried to do Chinese, but it didn't work out because I don't know what the console's capabilities, and it was always giving me rectangles. And one day I'll try to do that, but this is good enough for this project. So I will. So now that I have the buffer, I will actually update the Pong game to use the buffer too. Although it doesn't need it, it's pretty fast. But the benefit of doing that is I could kind of build sprites or images, little characters or whatever, beyond one character at a time. So if I figure that out, including the score and the text, to render it on the screen, that would be cool and fast. And then I could probably build a game. Think I'm still trying to decide what game I want to do. Maybe Breakout or something like that. But that's my goal. Well, thanks for watching, and I'll catch you next time. Thanks.